Thank you very much for the intro. As Hannah says, I'm James Smith. I'm the head of labs here at the ODI, and that means I look at the technology stuff that we do here, and so on. This is all my details. I'm Floppy on Twitter, and we have a ODI Labs account as well. And yeah, today I'm going to talk a bit about data infrastructure and blockchains and whether those two fit together and what's useful. So, if you've been anywhere near a presentation by the ODI recently, you'll be familiar with our concept that data is infrastructure for the modern world. The old, we often used to hear analogies like data is oil or something like some consumable resource that we can dig up and burn or something. Never quite understood. It's more like roads, it's connections, it's things that help us to join together and help us navigate to decisions. And so we think of, like I say, data as infrastructure, and this stuff is better when it's connected. So a road that's on its own, a private road, doesn't go anywhere, helps a few people, but not many. Connected roads, connected data have the capacity to help a lot more people and unleash much more activity. So data is infrastructure. The other thing you'll have probably seen, if you've been to any of these recently, is this idea of the data spectrum. Data exists along a spectrum. We found this the most useful way of looking at it, not as to whether it's big data or small data or smart data, whatever that is, or government data, but it's about who has access to it is the most important thing. And this is the data spectrum. And we go from closed over at this end, which is the stuff that that's really secure, that people shouldn't be that's being looked after by one set of people. It's your nuclear launch codes, things like that. That's maybe a bit off, even further down the other end. And then through this spectrum of shared in the middle, with increasing sharing based on different access rights, who can access things, and so on. So through things like your health records, for instance, which you want to be sure about who's getting access to them, but you do need other people to be able to access them. And then all the way through to open, which is data that's free for anybody to use, reuse, and share. And this is your open roads and your private roads and things like that. So it's again, the power comes often from using different parts of data across the spectrum. So we don't think of ourselves as just the Open Data Institute. We are the Open Data Institute, and we're always interested in connecting data across this spectrum. So, a bit of context there. What do? I head up ODI Labs. Like I say, ODI Labs is one of the programs within the Open Data Institute, and we look at the technology, we look at evolving the state of the art across the data spectrum by creating tools, standards, and techniques for the benefit of all. And we are basically a technical innovation team, applied research, a bit of prototyping. We do a lot of software prototyping, and we build tools that strategically help those help people solve problems along those in the data infrastructure area. We're about a team of 10. We've got a couple of PhD researchers, so we do some research all the way through to this kind of prototype development. And we look at 5 different themes in labs. We've got 5 different themes for our work. The first one is publishing. So how do we help people to get their data out there in the first place? We're really interested in collaboration. Once people have published that data, how do we help the users to improve and collaborate on that data, learning lessons from open source, things like that. We're very interested in discovery, and that's what our PhDs are working on. How do people actually find the data they want, or the data they didn't know they wanted? At the moment, everything's in portals, like the web was 20 years ago. What's PageRank like for data? Integration is looking at lots of different data sources, pulling them together to help make decisions. And all of this is underpinned by infrastructure. And in labs, we think of this as what is the technical infrastructure underpinning that data that allows it to be infrastructure for higher levels of society. And this is kind of where we focus and why we've looked at blockchains in this area, because they might be useful. So, are they? What I'm going to talk about today, are blockchains useful in our global data infrastructure? Probably yes. Short lecture. Probably they are. But, there's a but. Who's heard of blockchains? Everybody, I suppose. Technology, has anybody seen this diagram before? The classic hype cycle diagram. New technologies always go through these. Any technologist has seen all of their favorite technologies come through this hype cycle. People get really excited at the beginning going, oh my God, this could change everything. It could fix all the things I have. And then people realize that actually it's not quite all that, and you end up in the trough of disillusionment, and good ideas die in here, which is really sad. And then eventually, you know, you get to maturity and you get onto this where we're actually using it for the right thing. And we're definitely seeing at the moment that blockchains, that sort of distributed ledger technology is definitely riding up the peak, and the peak is pretty high. It's higher than a lot of ones that I've seen in my career. And what worries me about that is that the trough will be even deeper. And there's some really good ideas, and I want to get here as fast as possible. So what we're trying to do with everything we do at the ODI in this area is accelerate through this curve and make sure the technology doesn't crash in the trough. Context there. And because of this hype, there's a great quote from David Birch in a FinExtra article. The word blockchain has kind of got detached from its technological roots to become a bit of a Chrome wash term, which he uses, not a word I've come across before, like big data or cloud. And it's this superficial veneer of futurism. You know, oh, we'll look clever if we talk about blockchains. And there is an amount of that, and that's inherent in that hype cycle. So let's take a look. What have we done? What's a blockchain? Start with the basics. What is it? Essentially, once you decouple it from all of the ideas and the cryptocurrencies and all the things that are built on top, it's a database. It's not, you know, magic. It's a database. It's a database with some really interesting properties, and these properties are really important. First one is it's a database where lots of people can write to it. So there are many databases like that. You know, everybody can have credentials, write to a shared database. But with a blockchain, lots and lots of people can write to the thing, and they don't have to trust each other. It's trustless shared write. So you can have lots of people in the same system. You don't have to have trust. You don't have to have a centralized authority that's controlling who's allowed to write what and at what time. It's very, very distributed, decentralized. Through this decentralization, the network arrives at a consensus as to about what the truth of the database is. So people write into different parts of it, and the network arrives at consensus about the truth of the state of the whole system. And then because of that network, and because lots of different parts of the network are inspecting and checking what the truth is, you get a certain immutability. So things can't be changed. Once they're added to this, it's very, very difficult to go back and change history. And that's really, those are sort of some of the fundamental properties. There's a really good blog here, which is going to be very difficult to write down, but I'll give you a moment, which is on the multi-chain blog called Avoiding the Pointless Blockchain Project, or how to identify if you have an actual use case. Because if you don't need all these properties, you don't need a blockchain. If you have a trusted central authority, for instance, you can have a standard shared access database. It's okay, we know how to do those. If you don't need the immutability, if you don't need shared write, then, it's easy. So those factors are really important. What blockchain is not a magic bullet. It is not something that will solve all of your problems in one go, like a blue shell, for those who understand what the hell that is. I knew that was going to be a slightly maybe confusing slide to put in. So what have we been doing? ODI Labs. We have been working over the last 3 months or so. We've been supported by Deutsche Bank, some of this. He said, we want to help understand whether this stuff is useful, putting that very similar question. Are blockchains useful for global data infrastructure? And they've supported this work. So what have we done? We spent some time looking at the landscape. We looked at a whole bunch of different technologies that are out there and different applications. We've looked at things like the security, privacy, and scalability implications of blockchains, how they actually will work in practice, and raise some questions there. And we've done a bit of practical prototyping as well. So we've done a mixture of a bit of desk research, a bit of thought leadership, and then this sort of practical, well, let's try it out, see what we can do. So I'm going to go through each of these in turn. And so started by looking at what's out there, get an idea of the landscape. Looked at all sorts of distributed technologies, most of them blockchain-based. 89 different projects were identified in that, and we pulled out a bunch of trends. Of those trends, first one is these things are often very technically led. They can be very technocratic. They're a lot of the projects at the moment, because we're in this sort of early development of this stuff, it's not mature. We're looking at it as a, well, what can this technology do? And we're being led by the technology. Not really focused on the user needs, on what the actual problem is that we're trying to solve, and sometimes whether that problem needs solving. This is, one of the things we've noticed about a lot of these is a lot of them launch with a technical white paper about, here's how our technology works, rather than with a problem to solve, which is how you go about things in a mature technology. It's not a bad thing. It happens in all technologies. It's just indicative of where it is at the moment. And it gives you a lot of white papers to read. Again, because of the maturity level, the technology stack is very much in flux. A lot of these things are bespoke systems. They combine the platform and the application. So you don't have applications that are using a common technology stack. They're using a common platform on which to build different applications. There are lots of people who've, rolled the whole stack themselves. And again, it's early days, so that's to be expected. We are starting to see hybrid systems emerging, so not pure blockchain systems, but ones that use multiple distributed technologies together. So there could be a blockchain for something, another distributed file storage system for the actual data behind it, for instance. And this, to us, seems like it's the beginning of a technology stack. Things are starting to emerge, the commonalities. And we're also seeing emerging organizational models. So we're not just seeing traditional organizations building these things, we're seeing distributed organizations, decentralized organizations, using these tools to build decentralized systems, decentralized technology that then delivers decentralized services. So there's, there are whole new organizational models in here as well, which is quite interesting. And as to be expected, there's a very strong overlap with other technology trends. So the sharing economy, there are lots of people looking at, is it useful to have, can we do Airbnb with blockchains? Can we do Uber with blockchains? Things like that, those kinds of things. Internet of Things, again, very similar. How do we have a Internet of Things devices all sharing their data in this? And so there's lots of stuff going on in there. But what we've seen is there are very few really strong use cases at the moment. We're not seeing things that are, the killer app for blockchains hasn't emerged yet. There are lots of things that could be. There are lots of ideas out there, but we haven't seen one really emerge. The really strong one at the moment does seem to be supply chain data, tracking supply chains, because it's one of those where you have a decentralized system, a global supply chain network. It's decentralized, there is no central authority, lots and lots of people need to write lots and lots of things, and the data needs to be distributed around. It fits the criteria. So this is one where we've seen, we think there is definitely something going on there, and there's a few startups in that. I'll come back to some of those later. On the flip side, there's plenty of vaporware. There's a lot of stuff that really just doesn't make any sense. Space chain is amazing. Somebody thought, I can start a space program by blockchains. I don't really know. It's amazing if you look at the website. There's a sort of technology roadmap as to what they're going to do. They're 6 months, no, they're about a year in now, and they're about a year behind, and they haven't got the helium yet for their balloon. So, there's lots of fun ideas. But GeneCoin, upload your DNA into a blockchain. Nowhere on the front page of the website does it say why I would want to do that. One of the really interesting ones is Honduras' land registry. Who's heard of the Honduras land registry example? It's everywhere. Every single article that talks about, oh, blockchains will help, talks about this. It doesn't exist. It's Vaporware. The company that's building it came out around Christmas and said, yeah, actually, no, we haven't got anything, after about a year and a half. And it's still quoted in all of these reports, all of these articles. So you've got to kind of detect a bit of the that vaporware. And there are zombie ideas that just keep coming back with every new technology, that keep coming back. People go, ah, maybe this time I can get my idea done with the technology. And so, yeah, there's plenty of those as well. We then went and looked at some of the issues around storing data using these technologies based on the properties that it has. We looked a bit at scalability. So people often talk about the blockchain, like there's one thing. It's a technology. I can have my own blockchain. You can have yours. You can have yours. You can have yours. When people talk about the blockchain, I always assume they're talking about the one that's underlying Bitcoin. I think, though it's very, very unclear. People say, "Oh, I'll put it in the blockchain." It's very hard to tell. And there's a question about how many blockchains would be sensible. Do we want one big network that gives you a lot of security? It gives you a lot of security around the consensus, the immutability. But the database would be absolutely huge. And you'd be replicating, all the world's data to all the nodes. It'd be quite mind-blowing. So what's the balance between lots of small blockchains, one big blockchain? Where are we in the middle? And what happens if we need to actually split them apart, merge them together? Things like that. Also archiving them. If blockchains die away, if people don't get involved in them anymore, what happens to the data that's in them? There are plenty that have died off. Things like Namecoin is, I'm not sure it's quite dead, but certainly it's starting to smell a bit funny. What will happen to the stuff that's in there? How do we deal with that? There are more questions than answers, I'll point out in this talk, because we don't have all the answers yet. Linking data together, we're part of a web, right? We have a web of information, that's really, really powerful. How do we make sure that we don't end up with lots of silos of data in data infrastructure when we're doing this? How do we make sure things are not in, if they are in different blockchains, how do we make sure that we can interoperate between them? How do we manage ownership, licensing within that? And how do we link it through to the rest of the web? What's the URL for a transaction on the blockchain? I can look at any number of websites and view the data in a Bitcoin transaction, but there isn't a canonical single URL. So how do I link to it? How do I refer to it if I'm publishing another bit of data? How do I say, well, yes, I'm talking about this transaction over here? It's, they've all got a hash. You can see what that data is, but how do you then need to talk about which blockchain am I talking about? So there's some questions there as well. These are not unsurmountable. We just need to think about them. Privacy is a big one. Data in the blockchain is inherently open to an extent. Everybody has a copy of it. Everybody can have that copy to do with what they like. It's not open properly, as in licensed open, but it is there for everybody to see. Maybe a better way of saying that is actually very widely and publicly shared. That would be a much better way. I'm going to change the slide. That would be much better. But personal data can lie anywhere on the data spectrum. I can have some open personal data if I want to. I could open up my steps off my Fitbit if I like. But a lot of it would be closed. It's my choice. We make a conscious choice about where our personal data should lie on that spectrum. And things like in Bitcoin, the transaction data between accounts is all open. That's what makes it really stable and secure. What makes it safe is that the transaction data is open. Transaction data is intensely personal. You think about, do you want to put all of your bank statements online? Probably not. Not straight away, not without thinking about it. So people talk a lot about, the blockchain's secure, it's anonymous, it's private. It's not really. And those are tricky issues. And there's a big problem in immutability, especially when you come to government applications and things like that. Immutability, the network is so big that if you, so in a blockchain you have all of each time a new bit of data is added, it's cryptographically attached to the previous bit, if you see what I mean. And you can't change a bit further back without the entire upstream having to be changed. So if somebody does that on their own copy, it won't be accepted by the rest of the network, which is where this consensus comes in. Unless you control more than half the network, which has happened on some smaller blockchains. Unfortunately, when you look at government applications, we have this idea of official truth, which is a little bit different to actual truth, sometimes. Maybe fairly often, depending on how you look at it. And there are things like, I mean, initially, think about the right to be forgotten. You know, we've had rulings in Europe that say that something needs to be removed from a search engine because we don't want people to find it anymore. And that's backed up by the court. What if that data's stored in a blockchain that's immutable? We can't get rid of it. We can't hide it. Changing gender is a really important one, that you have the right in the UK, if you change your gender, to have that gender recognised back through history, to rewrite history and make it as if it was never the other way. In fact, it's an offence to disclose that the change was even made. Now, if your personal details were stored in a blockchain with something like that, yeah, you could revoke the old version, somehow maybe hide it away and replace it with a new one, but the fact the change has been made is still obvious, and that goes against legislation. And the problem is that technological truth and human truth is a lot more fuzzy. So when it starts coming to personal data and these things, we have to be really careful. People hiding from domestic abuse don't want their, may have their home address published in some official register if they were running a company or something like that, but they might want it to be hidden for particular reasons. Illegal information in the blockchain. What if I put in the names and addresses of a bunch of at-risk children, for instance? Everybody's got a copy of it. You've all got a copy now. You're all complicit. This is actually in the blockchain. This is the HD DVD decryption key. This is an illegal thing under the DMCA. There was a thing a few years ago, must have been early 2000s, where all the freedom speech geeks were walking around with it printed on their t-shirts. It's the decryption key for HD DVD, which was leaked through PlayStations, I think, many years ago. But it's considered an illegal number. But it's in the blockchain now. So, everyone's got it. Everyone's got it anyway, but the point stands. So how do we protect privacy in these situations? We can have a trusted network. We can have a small blockchain that only a few people can use, that stores the private information behind things. But then we've lost some of those advantages. We're not using the advantages. Do we still need a blockchain in that situation? We can use hybrid systems where the blockchain stores an audit record of another system, another distributed storage system. Alexandria does this. It uses a system called IPFS for storing information, and it uses Bitcoin transactions to verify what the state of those files were at a particular time. That's quite an interesting one. That's one of these sort of emerging technology stacks that we're seeing. IPFS is it's a radically distributed file storage system, basically. Stands for Interplanetary File System, I believe. It's one of these other distributed technologies. So that's like, if I put a file on there, it's everywhere. Everyone can access it. Or we can encrypt the data. But as we all know with encryption, especially given current government policy, encryption can be broken. Keys can be compromised. You can lose the key. You've got your data in a blockchain. You lose the key. You can't take it out, re-encrypt it. And algorithms get broken. The encryption we use now, 25 years' time, who knows? And then everything that's in there will be open. So, not sure about that. There's a great quote I saw. There's a really good post here, Privacy on the Blockchain, on the Ethereum blog. Just go and have a look at the Ethereum blog to find that. It's important to note that blockchains do not solve privacy issues. They are an authenticity solution only. So they allow you to check the state of something at a particular time. But they don't allow you to hide things away. So that's really important. So we did a little bit of prototyping as well. Our software team had a week. They went, right, what should we do? Let's put some data in a blockchain. So we created our own blockchain using a system called multi-chain, which allows you to create your own currency. It's really good, dead easy. They wrapped a simple API around that for storing some data. So we could store in strings, hashes, things like that. It's quite fun. And then we thought, okay, we can do that. What should we do with it? And one of our engineers has done a lot of work in the past with Food Standards Agency premises ratings. So we thought, let's make an audit trail for that. So we downloaded all the data from the Food Standards Agency, and we put it all into this blockchain. So we created essentially an audit log for those premises ratings. So if somebody went and changed, if somebody in the FSA went and changed the rating for the cafe down the street, for instance, surreptitiously, we'd be able to tell because it wouldn't match the hash anymore. And that can be held outside the system. We don't have to trust the FSA so much anymore. Might be useful. What did we learn? How the hell are we going to search this? How are we going to find the right establishment? If you've got to search the whole blockchain, you've got to index the whole thing. And then how do you know your index is secure? So again, have you lost some of the uniqueness? And how do we make people mine on this? How do we make people support this network? Well, the incentives for public data blockchains. In Bitcoin, where you've got a currency, there's a real incentive to join because you can earn money by being part of the network, by storing the transactions in the system. In our public sector one, what's the incentive? Does an economic incentive work? Who knows? Does the government run all the nodes? We're not really sure. Again, more questions than answers at this stage. Earlier in the year, we had a big report by the government chief scientific advisor, Sir Mark Walport, distributed ledger technology beyond blockchain, or beyond blockchain. This is the only time I've seen it with a space in it. Don't know why. And this was a great big document that, if I had to summarize it, it would say something along the lines of blockchains will solve all our problems. That's maybe a little bit flippant, but it was very sort of technology led. It was very much, oh, here's a new technology. Here's all the things we could do with it. And so we did an official response to this, saying things like, calm down a little bit, focus on the use cases, look at what's out there. There's lots of distributed technologies out there. Distributed systems are brilliant. They're going to be really, really, really important, but we have to pick the right ones for the right cases. So focus on the use cases, focus on the problem we're trying to solve, and pick the appropriate technologies, and pull together across sectors to come up with those issues, come up with those infrastructure issues, and work out how to solve them. So it was an interesting one. So the report's generally good, but it was very much like many of these projects at the moment, they're quite technocratic. So, are blockchains useful in our global data infrastructure? What have we found over the beginnings of our research over the last few months? Yes, they are. They're going to be useful. It's a really interesting technology. It's got some really interesting properties that we've not seen before in other database systems. But it's not going to be for everything. It's not going to solve all the world's problems. And unfortunately, some people are saying, this is going to solve all the world's problems. Never believe anybody who says that their answer will solve all the world's problems. We have to start from the user needs. We have to look at the problems, and then we have to pick the technologies to suit them. But it is going to be useful, definitely. And it's fascinating. As a technologist myself, it's like, oh, here's a whole new, exciting world to look at. So, the good stuff. Supply chain provenance is a really interesting use case. It's, like I said, it's a distributed system. There's no central authority. It powers the world, right? It's really important. And they do it by handing around bits of paper. Provenance.org are a company that were in the ODI startup program. They're now, I think they've got funding from Innovate UK for their next round. They're building on Ethereum, a blockchain computing platform, to build their supply chain provenance systems. And that's really, really interesting. What I love about provenance, and why I think they are a really good use case for this, is that they were doing this before any of us had ever heard of blockchains. They already knew they wanted to solve supply chain problems. And then they went, oh, this technology fits. That is the right way around. Everledger's a really nice one. Everledger track diamonds. So it's a sort of narrow supply chain provenance for diamonds in particular, making sure they've not been altered, cut, faked, or whatever. They have a very nice, again, distributed system, no central authority, and they have a very nice way of making sure that their physical object is exactly the thing that is represented in the blockchain. The blockchain is a digital artifact. You have a hash that identifies a thing. With a diamond, you can do that. You can look at it and look at all the patterns. You can classify it and say, this is a mathematical description of this diamond. which is really nice. And I think they actually are doing something interesting. It's really, really hard to do that with, say, a pig. What is my mathematical description of this particular pig? And how am I going to be sure that it flows correctly through the system? Provenance, hopefully, I think, are doing some good stuff on that. Sam Smith, who some of you may know, is about to publish a article in the next week or so where he's outlining a use case around document revocation. So knowing that people's passports have been revoked. Again, big international system. Identity documents, you want to know very quickly whether somebody's identity's been revoked. You don't have to leak personal information. All you're doing is saying this number isn't valid anymore. That, I think, is a really interesting one, and one that we might be able to build and use quite quickly. The bad stuff. Benefits tracking. Every time you have a conversation about blockchain, somebody goes, oh, we could use it to track people's benefits. It comes out all the time. It came out very strongly in the Walport report. It's a zombie idea. It will not die. It keeps coming back time and time again with every new round of technology. This is an old idea. And the thing is, with a lot of these sort of government schemes, it's an intensely political and social choice. Do we want to do this, is the question we ask first. Not, can we do this? And even if we do want to do it, pretty sure I could do it with a prepaid credit card, right? We don't need a blockchain. Land registries, an interesting one. We have a reliable central authority for a land registry, although we are about to sell it off. So maybe that will be, maybe that'll be more useful in the future, I'm not sure. And in places where there are not reliable central authorities, perhaps that is not so bad, but you know, we don't really have that problem here. Maybe we have it elsewhere. And magical thinking, technology will save us. Watch out for that, because technology will not save us. Society will work out how to save ourselves and find some technology to help. Things to watch, things we're keeping really interested eye on. Ethereum's really interesting, general platform for this stuff, and it has capability for things like smart contracts, which are, I think, going to be the sort of the next level of this stuff. The ability to encode agreements into code and allow automatic changes of things to happen. It's quite vague, not a thing, but it's really interesting. Colony.io is an example of just, things that are appearing in distributed autonomous organizations. What do, you know, how does this work if we want to form a loose collective of people and agree, you know, form contracts amongst ourselves to agree what we do with it? It's really interesting. And I think democracy platforms are going to be interesting as well. Voting applications, I'm not sure quite what, but I think it'll be interesting to watch. So, pretty much done. Yep. What are we doing next? We're going to publish this stuff as a report. We want to look at more technologies, looking for use cases that are useful to help explore what's actually going to be good. And we're running an event on June 14th about data infrastructure and about some of this stuff as well. So we're going to carry on looking at it and hopefully coming up with some of the answers to those questions. Thank you.